Antarctica is fifth in size among the world's continents. Its landmass is almost wholly covered by the vast ice sheet, um, lying almost concentrically around the South Pole. Uh, Antarctica, the name of which means opposite to the Arctic, it's the southernmost continent, a circumference that has the mountainous consequences for all aspects of its character. It covers almost 5.5 million square miles. It's around 14.2 million square kilometer, and it would be essentially circular except for the outflowing Antarctic Peninsula, which reaches towards the southern tip of South America. It's approximately like 600 miles, approximately 970 kilometers away. And for the two principal embayments, the Ross Sea and the Weddell Sea, these deep embayments of the southernmost Pacific and Atlantic Oceans make the continent it's somewhat like pear-shaped, diving it into unequal-sized parts. The larger is generally known as East Antarctica, and the rest is known as the West Antarctica because it most lies approximately like in the east longitude and the western longitude. The smaller, wholly in the west longitudes, is generally called the West Antarctica, like I explained. So it's approximately like 2000 miles, which is like 3200 kilometer long, the Transantarctic Mountains. Whereas East Antarctica, it consists of the ice covered plateaus. West Antarctica consists of an archipelago of mountains, islands covered, bonded together by the ice. The continental ice sheet contains approximately 7 million cubic miles. It's approximately like 29 million cubic kilometer of ice, representing about 90% of the world's um, total. The average thickness is about 1.5 miles, which is about like 2.45 kilometers. Many parts of Ross and Weddell Seas are covered by ice shelves or ice sheets floating on the sea. These shelves, the Ross Ice Shelf and the Fletcherone Ice Shelf, together with the other shelves around the continental margins, constitute about 10% of the area of Antarctic ice. Around the Antarctic coast, shelves, glaciers, and ice sheets continually calve or discharge icebergs into the seas. Because of this vast ice, the continent supports only a primitive indigenous population of cold adapted land plants and animals. The surrounding sea is as rich as life as the land is barren. With the decline of whaling and sealing, the only economic base in the past Antarctica now principally expose the results of scientific investigations that lead to a better understanding of the total world environment, which leads to global warming. The present scale of scientific investigation of Antarctica began with the International Geophysical here (IGY) in 1957 to 1958 approximately. Although early explorations were nationalistic, leading to territorial claims, modern ones have come under the international aegis of the Antarctic Treaty. This treaty, which was unprecedented landmark in the diplomacy when it was signed in 1959 by the 12 nations, that preserves the continent for the non-military and scientific pursuits. Antarctica is the most remote and inaccessible continent. It's no longer as unknown as it was at the start of IGY. All these mountainic regions have been mapped and visited by geologists, geophysicists, glaciologists, and biologists. Some mapping data are now obtained by the satellite rather than observation on the surface. Many hidden ranges and peaks are known from geophysical surroundings of Antarctic ice sheets. By using such sounding instruments, systematic aerial surveys of the iceberg terrains can be made. The ice-choked and the stormy seas around the and Antarctica along hindered exploration by wooden hull ships. No lands break, the relentlessness force prevailing west winds as they race clockwise around the continent, dragging westerly oceanic currents along the beneath. The southernmost parts of Atlantic, Pacific, and Indian Oceans converge into the cold oceanic water mass with singularly unique biologic and physical characteristics. Early penetration of the southern or Antarctic Ocean, as it has been called, in the search of fur seals led in 1820 to the discovery of the continent. Icebreakers and aircraft now can make access to it. Although it's still not without hazardous and stormy conditions, it gets crazy. Many tourists have visited Antarctica, and it seems like that, at least in the short run, scenic resources have greater potential uh, for the economic development than to the mineral and biological resources. The term Antarctic regions, like you can see in the picture, refers to all the areas, oceanic, island, and continental, lying in the cold Antarctic climatic south of the Antarctic waters meet and mix with the cold polar waters. For legal purposes, also, Antarctic Treaty, the arbitrary boundary of latitude 60 is used. It's approximately like 60 degrees, the boundary latitude. The familiar map boundaries of the continent, known as Antarctica, defined as South Polar landmass, and its all non-floating grounded ice are the subject to change in the future changes in the climate. The continent was ice-free during most of its length, and there is no reason to believe it will not become so again in the probably distant future. Now let's talk about the physical geography of the area. The geological evolution of Antarctica has followed the course similar of that to other continents. It started around like 3 billion years into the early Precambrian time. Similarly, in the patterns of crustal and biological evolution in the southern continents can be traced about 70 million years ago. Late in the Mesozoic area, plant animal migration routes that apparently had interconnect all the southern continents were largely cut off by outside of the Cenozoic area. So it was about 66 million years ago. The continent became isolated with the opening of the Drake Passage between the continent and the South America. Sometime between 49 million to 17 million years ago, a time when land mammals diversified and flourished, somewhat populating all the other continents of the world. The Antarctica had long been thought to be a migratory point for marsupials moving between southern continents in the early Cenozoic time, but documentation for the theory was not discovered until 1982, when the first mammal remains, the marsupial fossil, were found on Seymour Island in the Weddell Sea. The subsequent growth of Antarctica ice sheets cut off any further migrations by land ice. Now let's talk about polar ice. Antarctica has abundant fossil evidence and its climate and the terrain. At one time it supported far more populous flora and fauna, and today few seedless plants and primitive insects. Much of Antarctica was densely forested in Mesozoic times. It was about 252 million to 66 million years ago, dominated by southern conifers, podocarps, araucarias with undergrowth of rainforest types ferns and juice from trees, particularly southern bleach. Some fungus appeared during the Cretaceous period. It was about 66 million years. According to some scientists, the discovery of Nothofagus pollen that dates approximately to 3 million years ago suggests that those fungus may have lingered as Antarctica drifted the pole cooled and became glaciated. It's all a result of global warming that we see right now. Remains of luxuriant extinct floras as well as fossils of Mesozoic dinosaur, amphibians, etc., have been discovered, and these compare so closely to those of other southern continents that may have impressed geologists or fascinated them in the relative discovery of the conjugate of these lands in a single giant continent called Gondwana. Continental stratigraphic evidence and the dating of the seafloor seem to indicate the supercontinent broke apart or along the Jurassic. It was around 180 to 160 million years, and such fragments such as Africa, Australia separated from Antarctica in the Jurassic to Cretaceous time. There was like 201 million years in the early Cenozoic area. Now, modern theory ties mobile zones into interaction and just to immense crustal plates. Modern plate boundaries may be far different from ancient, presumably marked by the old belts. Also, more research has been concentrated on attempting to match intercontinentally the detailed structure of the opposite coasts, such between Antarctica and Australia. And let's talk about the structural framework. Most of Antarctic geography lies beneath the vast regions of snow and ice. It makes about 95% uh, of the surface terrain. No one knows what important segments uh, considered, such as the topography, which has been mapped only by CMA reflection, although the grace uh, Antarctica ice sheet, the extraordinary thick cover, the extremely difficult working conditions, and the tremendous expanse of the mounting expeditions into the remote areas have long led geological knowledge of Antarctica far behind that of other continents. From the results of mainly British expeditions early in the 20th century, the concept arose that Antarctica is made up of two structural provinces: long stable Precambrian shield, young Mesozoic and Cenozoic mobile bulk in West Antarctica. The average thickness of the crust of both East and West Antarctica approximates of that other continents, although it has been postulated that the West Antarctica might be an oceanic island of ice were to melt. It's a crustal thickness similar to that of other continents. It's like 25 miles thick in East Antarctica. Significant earthquakes are not really recorded along this or other known faults in Antarctica, the most seemingly quiet of all continents, in which most minor activity is associated with the surrounding oceanic ridges and volcanoes. There are a lot of volcanoes in Antarctica. It doesn't seem like it, but there are. However, the occurrence of only one unusually large earthquake, it was around 6.4, which happened in the Bellingshausen Sea as a really big earthquake in 1977, suggests that the Antarctic plate may have greater seismicity than generally believed. The ancient crust of Antarctica must be highly mobile, and the configuration of the continent today. Moreover, at the surface, the rocks were uplifted and the mountains were carved by erosion, sediments filling up places in on the Earth's crust. Again, this cycle was 400 million years ago. Let's talk about Glacier and Seas. Antarctica provides the best available picture of the probable appearance in 20,000 years ago in North America under the Great Laurent Ice Sheet. Some scientists contend that the initial Great Glacier was more than 14 million years ago. Other glaciers, such as those forming into the Central Range perhaps early as the 50 million years ago, advanced down east to call into the sea the West Antarctica. Fringing ice shelves were built and later became grounded as glaciation intensified. Local ice caps were developed, covering West Antarctic island groups as well as the mountain ranges of East Antarctica. Ice caps eventually coalesced into the great ice sheets that tied together West East Antarctica into a single continent that is known today. Except for the possible major delineation, as 3 million years ago, the continent has been largely covered by ice since the first glaciers appeared. Moreover, let's talk about the plant life now. So, the cold desert Antarctica supports only one improvised community of cold tolerant land plants. They are really resistant to cold. They are capable of surviving lengthy winter periods of total or near darkness during photosynthesis because there is no much sunlight and the heat, so photosynthesis cannot take place. The growth must occur in the short summer burst, lasting only few weeks, a month or two, depending upon such diverse factors as latitude, seasonal snowpacks, elevation, topographic orientation, wind, and moisture. In both the substrate and the atmosphere, moisture is the most important single variable and is provided mainly by the atmosphere water vapor and by the local melt supplies from the fallen snow drift, snow, permafrost, Stream running off is exceedingly rare. Extreme cold havings are inhabit growth even in summer in most areas. There are, however, certain areas at high latitude and high elevation that have local microclimates formed by different solar heating of dark surfaces, and these areas are able to support life. The importance of such microclimates was demonstrated by the second Bird Antarctic expedition, which occurred in 1933 to 1935, which found that lichens in Maryland grew preferably on darker colored heat absorbing rock. So we talked about the plant life, let's talk about the animal life. The native land fauna is wholly invertebrate, apparently climatically less tolerant and easily dispersed. The fauna follows plant colonization of newly deliberated regions and therefore is not widely distributed. The Antarctic microfauna includes helozoans, roofers, targus, nemours, and aquatic protozoans. Like you can see in the picture, there's a seal, there are so many things on that. The protozoans dominate soil and freshwater communities. Terrestrial microfauna consist entirely of arthropods, many species being parasitic on birds and seals. Like you can see a picture of the seal, there are so many parasites on that. There's penguin right there. The principal arthropod groups represented include Carnia, which are basically mites like dust mites, Malphugidae, biting lice, Colima springtails, Anoplura, sucking lice, striper, and cyper fleas. Two species of beetles, probably alien, are known from the islands near the Antarctic Peninsula. The dominant free living forms live under the stones, reproducing plants. Now let's talk about the birds. There are 45 species of birds that live around the South Atlantic convergence, but only three are mainly in there. So basically, we talked about what is Antarctica like, which is the coldest place on the Earth. The temperature in the winter is cold enough to freeze water all the time. It's too cool for people to live there, but scientists take turns going there to study the ice. Tourists visit Antarctica in the summers. The oceans around Antarctica are home to many types of whales. Antarctica is also home to seals and penguins. Now, according to NASA, the satellite images to study Antarctica, NASA uses satellite to study Antarctica. They want to know how Antarctica is changing. Scientists want to know what the changes in the Earth climate are doing to Antarctica, how the climate is affecting the whole world, like you see the global warming going on right now. One tool that NASA uses is ICESat. That stands for Ice Cloud Land Elevation Satellite. Using ICESat, NASA can measure changes in the size of Antarctica sheets. It also helps NASA understand how changing polar conditions, such as ice, may affect the rest of the planet. Melting ice sheets in Antarctica may change sea levels all over the world. NASA uses instruments that have helped scientists create detailed maps of Antarctica. The maps help researchers when planning trips to Antarctica. They also give people the clear view of the continent. What can we learn about the space from studying Antarctica? It's a good place to find meteorites, rocks that fall from space to Earth. Scientists more meteorites in Antarctica than any other place in the world. Lots of meteorites fall on Antarctica, which would probably affect the lives there. See in the picture, Antarctica is really pretty though. There's a moon right there. So do you see like a picture? Scientist is doing some research over there. Now sends teams in Antarctica to learn more about the planet Mars. A lot of research about the Mars is done from Antarctica. Tested robots later. The robots that are on Mars were tested on Antarctica. It also goes to Antarctica study astronomical like a desert tested robots. it goes to Antarctica, study astronaut nutrition. People like there are Antarctica winter astronauts in space are not in sunlight, so Antarctica is a nice place to for mainly astronomical reasons to help scientists get many vitamins. So I want to live in Antarctica someday. Give it a try. Go for it. Thank you.